Oh, hello there. I guess what's going on? I know it's been a little while. Merry Christmas, Happy Kwanzaa, Happy belated out Hanukkah, and all the jazz, and a happy upcoming New Year to all those, and a happy Festivus for the rest of us. But so it's been a little while. I've been spending some time trying to learn a whole bunch of stuff that I have been supposed to. Try to learn about Lagrangians and everything. Long story short, I started to break down, and I'm like, all right, I can read all this stuff, but show me how to construct a Lagrangian. Tell me what all these different dimensional stuff and things are. Long story short, the purpose of today is basically when we had earlier versions of chat and a lot of these AI and large language models and different agents and everything. Hey, Jax. Basically these things, a lot of time you would say something and be like, oh, this is a phenomenal thing, and would say a lot of like nice things. And that's fine if you like nice things and everything, but ultimately it's like, well, is there any merit here? It's like, as a assistant, or let's say a colleague, a friend who has read the entire internet. That's the thing. It's like I'm not necessarily looking for you to do something. I'm just like, take the corpus of knowledge we have. Let's compare it. Does this make sense? Is there any there? And a lot of times it's like, oh, this is a fascinating thing. And long story short is, yeah, the more recent ChatGPT 5.2, at least I've been working with, it's not necessarily going to say all those kind things to you, especially if you phrase it, or at least I was trying to, let's frame it in the form of some rigorous scientific research, be open to new ideas, but it's like let's be realistic without just going down dead ends and stuff. And I was starting to post some things, and I was going a little bit of back and forth before, and let's just say some answers I gave before where it's like, oh, this could be fantastic, or everything. It's like, no, you kind of have a misconception here. And this is other stuff that I've heard from like other folks that have pointed this out. And even as a person that like went to the Wolfram Summer School to like study some units and everything, it's like, okay, I'm still getting a bit of the gist and everything. And I could still make the argument saying, oh, we have a coherent system of units based upon our coherent system of units. It managed to spell out explicitly the error that I was making. I was totally wrong. My argument does not hold water unless the universe literally holds water. Not just literally holds water, but literally holds the reference density of water, which is one within a centimeters, grams, yada yada yada. Okay, let me show what I'm saying, and this is something that I kind of actually missed until more recently. So let's go to our actual definition. This is like how the current, what is it? International Bureau of Weights and Measures currently defines the meter. So let me share this right here. Okay. So I did put us up a little clip from a little bit further in my the little presentation I gave over at the Wolfram Institute about like the history of SI, how we got here, and potential methodology within Wolfram physics. Okay. That's that's fine. Still needs a little bit of updating there, but here's what we literally have it defined. Okay, we got the speed of light divided by the frequency of cesium-133. Okay, what the heck is this here? So the literal definition is these are the digits associated in hertz of the hyperfine ground state hyperfine splitting frequency of the cesium-133 atom. Yeah, right what it says right there. That's literally defined. Okay. And this is the speed of light in meters per second. Okay? Because we're using our definition. So what are we doing? We're stripping the dimensions. We're relating this ratio. And then we are literally relating this, the inverse ratio. So now we're taking the numbers of cesium-133, relating to the speed of light, and then relating the numbers and multiplying by the transition frequency. And by definition, we get out 1 meter. Okay. That's literally, this is the other way, because I showed it one way in my presentation. And that's fine. And again, this is a coherent system of units. Once we set our basis, even if it's an arbitrary basis, as long as force equals mass times acceleration. Energy equals force times the distance. And then power equals energy divided by time. So it's kind of like, again, take all the heat and the thermodynamic heating stuff out of like a clothes dryer. Okay. A force upon the barrel of a clothes dryer. Just like big metal barrel, boop. Okay. You give it a little boop and cause a little bit of acceleration. However, if you want to spin all the way, that you're going to have that force times a distance so it can go around a revolution, okay? And that's how we get the energy. And if you actually want your clothes dry, again, throwing aside the heating thermodynamics part, because again, quote unquote spherical cow, we want to assume the simplest, most basic situation so we can deduce and or figure out what the heck's going on. Okay. So if you got an energy, if you've got enough force for that barrel to do one full revolution, okay, it's traveled that to pi distance per its radius. Okay. Now you want to keep doing that. So you're going to need to have that energy over a period of time, aka power. So I unplug my laptop. I could probably do this for about an hour and a half or so, maybe 2 hours. It's a fully charged battery, hopefully. Now my performance is going to start to decrease, but again, those are anti-oscillatory factors or additional factors that maybe we don't talk about as much. But okay. So here's the thing. Okay, it equals 1. That's fantastic. But here's the thing. If we were just relating two constants in nature, cool. This is the thing that Chat kind of pointed out to me, because that's the whole thing with a fine structure constant, because it's using all constants in nature. So irregardless, because I'm in the greater Boston area, so I can say it that way. So irregardless of whatever the units might be, you're going to shift those units. Everything's going to shift in flux. Yeah, a little play on the word, so to speak. However, these were already defined by our convention. Let's take our convention out of it. And this is the part that I still kind of missed. Because if we literally did speed of light divided by the frequency of CZ133, if we get out 1 and we wanted to find the meter by that, that's cool. Because we've now got 2 actual... actually, I'm not even sure if that is true. Because these would need to be the exact same magnitude. Huh. Long story short is, even still, you don't get 1 meter. Because even if we invert it, so the ratio is going to be about like 30.36 or something like that. So, yeah, 30.66. If you just did hyperfine transition frequency, that is not 1 meter. This was something that I had seen there. To be fair, I did not spend enough time. And even after going through that whole project again, I'm like, oh my god. This is a conversion factor that I kind of missed out. Okay, so let's actually share the point where you have that point where it's like you're bringing up and it's like, all right, I'm just kind of going with the flow, seeing if it's seeing inferences. And then it gets to the point where I'm going through, it's like, well, if you did this, I'm like, let me actually do that. And then as I'm in the middle, I'm like, oh, I see what you did. So let me unshare this. Let's bring up the chat log in question. Just because, and again, there could be some caveats, but no, I go back to this just because there's a quote again, just from the Professor Feynman Twitter account that's often attributed to him. I have no idea if he said it, but probably not the first. But the easiest person to fool is ourself. Again, I can say words, I can make an argument, I can still say it's based upon our reference. However, here's the actual point. Because long story short is, I've been saying, to the point where I've literally printed it on a t-shirt, where it's like, if you take the square root of The elementary unit of action, you define it by the reference of action, the joule second, you multiply by the Planck mass. You couldn't coincidentally get out a measurement within the ballpark, and it's been well within the ballpark of different measurements of the Higgs boson. And to be fair, even Chat pointed out that one of the numbers I was quoting was the analysis for like the 10-year summary of CMS, where it actually did have a more recent measurement that was like two to three sigma away. So it's like, yes, it's still in the ballpark, but it's, again, might just be a numerological coincidence there. So long story short is it was talking about in different units here. So right now this is in erg seconds. Oh, no, actually, no, this is just in ergs, because ergs is energy. Erg seconds is different. There would be a space here, and it even confuses Wolfram out. This is in ergs, units of energy. So long story short is every joule is basically 10 to the 7 ergs. So there's a factor of 10 to the 7. So I'm like, all right, everything's just going to shift. Everything across the scale in a coherent system of units will shift by that magnitude. So i.e., if you had something elementary like the Planck length, if you double the Planck length, if you double the meter, the Planck length will, by definition, literally have to double. If you cut the meter in half, the Planck length, by definition, will literally cut in half. And then all those other associated units, to maintain coherence, will need to shift by an equivalent magnitude. Okay. So if we account for that shift, I'm like, oh, look, it's the same magnitude. But as we can see, even as I'm typing this, I'm asking, does changing the coherent unit system matter? See the image. I converted the Higgs and Planck mass energies to ergs and computed the same dimension. Is supposed to be dimensionless ratio. So this is h bar in joule seconds. Okay, the elementary unit of action, Planck's reduced constant, is approximately it in joule seconds. Okay. Oh, I think I see. Erg seconds shift that ratio of h bar down 7 orders of magnitude. I.e., the only way we'll be able to claim significance is if we somehow manage to choose the correct quote-unquote scale of expression. Chat responds, you've essentially answered your own question in that last sentence, and you're exactly right. Let me formalize it carefully and close the loop so the conclusion is airtight and satisfying, not hand-wavy. Okay. Does changing the coherent unit system matter? Yes. For dimensionful numerical quantities, for dimensionful numerical coincidences, it matters completely. Even in a coherent unit system, SI, CGS, natural units, the numerical value of a dimensionful constant is not invariant. Coherence guarantees consistency of equations, not invariance of raw numbers. What your erg calculation shows is that the decisive diagnostic. Okay. I'm literally just going to read through this because I'm like, okay, it actually did a good job. Personally, I occasionally, it does still make mistakes, and occasionally I point out you got to correct it, but it seems to be doing a far better job, at least, because again, I can say words, that's fine. I would love for stuff to be true, but just because I want something to be true doesn't mean it's actually true. And again, combine that with if the easiest person to fool is ourselves, why wouldn't I just assume that I'm probably just fooling myself? Because if there's so many other smart folks out there, why should I just assume, oh yeah, I just stumbled upon this? And again, I say that all the time, but it's like, if we want to actually do science, we want to cast off our misconceptions. We want to make sure we're actually, the whole goal of science is to be less wrong. What is the truth? I have no idea what the truth is, but I at least seek to be less wrong. I can write fiction, and I love fiction and stuff. I mean, who doesn't love a good story? But if we want to actually be rigorous, we need to maintain and not. Here's the thing. If we are going to criticize somebody for anything, and especially within science, one of the big things we say is, there's hand waving there. And I do that too. It's like, well, how did universe begin? It literally is like, well, there were quantum fluctuations. So there's hand waving built in, i.e., there's some magical wizardry going on. Now, I can say that, and I can poke a little bit of fun and jest at that because, well, number one, none of us were there, so who really knows? Maybe we've always been here. Maybe that would explain a lot. Now, if I'm going to criticize somebody for doing hand wavy stuff, if I'm doing my own hand wavy stuff, how the heck can I criticize somebody unless I'm willing to criticize myself as well for doing hand wavy stuff? Because we want to be fair and consistent as best as we can. So the hand wavy stuff is this. All right. Here's what our erg calculations proves. This is key. The computed dimensionless ratio of the energy of the Higgs divided by the Planck energy squared. That ratio is unit invariant, where I use joules, ergs, or bananas. Who doesn't love bananas? The ratio stays the same. That part is physically meaningful. Now observe what happens next. In SI, the ratio happened to land near the numerical value of h bar, elementary unit of action, in joule seconds. Okay. In centimeters gram seconds, the same ratio now lands near h in erg seconds. Okay. And erg seconds differs by joule seconds by exactly 10 to the negative 7. Shift is not physics. It's unit bookkeeping. This is literally the smoking gun. All right. Why this kills the idea of a special coincidence? Now I can see the iron rule. All right. If a numerical coincidence survives unit changes, it may be physical. If it shifts when your unit changes, it is a coordinate artifact. I like that expression because I've heard folks say that before. Isn't that one of those things where people are saying for black holes or something like this? It's like it was like coordinate decision. Now again, those were a heck of a lot smarter, more brilliant people than me. I'm going to assume they probably took a lot of that into account. Who knows? All right. So a coincidence. It shifts by 7 orders of magnitude when we switch joules to erg. Tracks the numerical size of h in the chosen system. Okay. Therefore, it cannot be an invariant statement about nature. AKA, if the magnitude did not come out to be the same 10 to the minus 34, and it literally matched the shift, which was 7 orders of magnitude, well, actually, no, that doesn't make sense. It would just have to be the same dimensionless ratio. That's the thing. Ultimately, it gives a different dimensionless ratio shifted by 7 orders of magnitude, because we can see here. Wait a second. See, I'm going back and forth on myself here. Yeah, no, that doesn't make sense. Okay, no. That's the magnitude. Okay. The unit system doesn't explain why, because h bar would shift along with that. So, okay. Again, I did a project on this. You would think it's like, oh, you spent some time studying this. It's like, you spent a lot of time studying it. I'm sure, heck, there's much more well-versed people, well-educated, younger than myself, that have I'm sure a lot more understanding. Boy. Let's see. What dimension is a word? I think we're reading in 2 dimensions right now, my friend. Yeah, magnitudes matter. Okay. Because those magnitudes will shift. However, within that unit system, the magnitude of h bar has shifted by that number, so it's no more, you can't say it's equal to h bar. Now, again, even in the video, I have a little caveat there. What is my little caveat? And it actually requires additional caveats. Now, again, Number one, the number I was citing, that 138.38 gig electron volts, sorry, that was from CNS's analysis, where there were a number of other measurements, because I think the initial Higgs boson magnitude was around 126, 126 and a half-ish between CMS and Atlas. I had about, I don't know, about a giga electron volt and giga electron volt and a half of play there. And again, that's about at the squared relationship is about 10 to the minus 34. It's like, okay. But now, rather than being like 0.1 or 0.2 sigma away, yeah, we're more pushing about 3 sigma, which doesn't mean it rules it out. It also tends to lessen some of the credence, unless you had some future ones, measurements that seem to start pinging around it again. But again, it's in the general ballpark. It ain't at home plate, or at least like reaching out for home plate. It was really close when I used that other number, but it also matches a lot of the standard model data as well. So, however, again, in order to do that, you're going to have to say that, all right, the SI system itself is the actual correct quote unquote system. How the heck could that possibly be the case? Let's get into the speculative side of things. I don't have evidence for this, but if you were to go back, the original definition of the kilogram was actually the gray. It was about 10 deciliters of water. What is that? That's 1 kilogram. Long story short is you put enough of those in there. The conventional density of water is 1 cubic meter is 1,000 kilograms. So there was originally baked in a relationship between the kilogram and the meter via the density of water. Okay. That was something that I had first heard Rick bring up. And then even when doing the research, it's like, oh, yeah, we call that the gray. I'm like, all right, that's cool. That's why, like, your difference between the centimeters, grams, and seconds in the meters, kilograms, seconds, it's like 3 orders of magnitude. Well, why? Well, we're using meters versus centimeters. That's a difference of 100. Kilograms and grams is a difference of 1,000. All right. It starts to make more sense that way. But then again, it's like, all right. The density of water is actually about general standard temperature. It's actually not 1. It's 0.997. Yada, yada, yada. All right. I think the next digit is like a 0. All right. The maximum density of water, I think, matches for about 5 to 6 significant digits. Like 9, it's 0.99999. Okay. To be fair, there have been government literature, and even I think the most there are some folks that have calculated and or have claimed to measure it at exactly 1 gram per centimeter, or literally reference density of 1. Is that the case? Could I, okay, for sake of argument, I could imagine under a particular temperature and pressure, water is precisely 1 gram per cubic centimeter, or 1,000 kilograms per cubic meter. Let us assume that is the case. I could imagine that. All right. What the heck did we just do? We are now saying the reference density, the correct reference density in order to measure constants in nature, is using the reference density of water. Can you see the chicken and egg problem at this point? It's like, wait. So, if at the time of quote unquote creation, if there was a beginning, let us assume that there was a beginning, universe at that point is like, well, it doesn't exist yet, but we're going to use the reference density of water for setting the constants of nature, as the actual quote unquote correct natural scale. What type of weird stuff have I been smoking? It, you could see literally, it's like, wait, how could we do a reference density of water if we don't even have stars yet? If we have early galactic formation, it's like if you would say reference density of hydrogen or something. Oh, okay. I mean, to be fair, we don't even believe there was hydrogen. We didn't even have Big Bang nucleosynthesis yet. What do we assume? We assume quantum field theory. Why? It seems to have the maximum predictive power of any of our physical scientific theories right now. Okay, well, it's about the same magnitude as general relativity, at least according to Sir Roger Penrose. Again, that's an appeal to authority, because I have a clip of him saying that Newtonian gravitational mechanics seem to have a precision of about 10 to the 7, whereas Einstein gravity has a precision to about 10 to the 14. Okay, or 1 to 10 parts in the 14. All right. That's pretty good. The anomalous magnetic moment of the electron, it's like about 14 significant digits. And again, it's like, do we have all of quantum field theory evaluated to that level? No, I'm pretty sure that's probably the only one. It's muon is probably about 13 significant digits for its anomalous magnetic moment, I think last time I checked. And again, there's some error in there. But a lot of our constants and everything, it's like we get them to like 10 significant digits or so. Like mass, we got like mass of the electron and protons about like 12 significant digits. Yeah, it's pretty dang high precision there. So it's like, all right, what am I gonna say? Let's throw out quantum field. To be fair, in one of these chats, at one point I entertained the crazy idea. I'm like, well, what if H bar was to set for this? Like, how the heck would we have to go about it? It's like, well, you'd have to do some thermodynamic, kind of like almost stochastic Boltzmannian method, and you have to like thermodynamic dispersion. I can't, ultimately, it sounds like you're trying to cut a couple temperature at a time. Where I'm like, Dan and I did kind of a deep discussion about that, and I would like that to be true. Do I have proof of that? No. But then again, I'm like, well, if I take H bar and if I divide it by the Boltzmann's constant, I do get the atomic heat constant, which is basically Planck time coupled to, or Planck time times Planck temperature. Oh, that was a lot of things to say, and they both have Planck T's. And again, standard notation, time is the small t, temperature is the big T. Why? Well, time on our scale is like 10 to the minus 44. Temperature on our current scale is 10 to the 32. That's how I used to make when I was doing replicating some of Thad's calculations. I'm like, why am I 76 orders of magnitude off? I'm like, I got a magnitude minus 44 and then a positive magnitude 32. I'm like, yep, that's a 76 magnitude order difference. That's how I learned. Make a whole bunch of mistakes, and it's like, all right, if I'm still making mistakes, that's fine. Just want to learn to them. So I'm like, all right, so even if I want some there, it's like the closest thing I got is I have to use the reference density of water at 1, which our SI system was really based off. I'm like, okay, as crazy as the original idea might be, I mean, that literally seems like orders of magnitude crazier. It could be the case. Maybe it's literally just all water. Who knows? I mean, coincidentally, every time we try to figure out a way to generate more power and everything, what do? We boil water. Why? Seems to be really dang efficient. At least for our current technology. Can we do more efficient things? I would love so. I would love to see sustainable fusion, like actual room temperature superconductors. Oh God, the superconductor thing is very often a misnomer, in my opinion, because new high temperature superconductor. It's like, all right, superconduction is here. It's like when we say high temperature, we mean high in reference to like, I don't know, like absolute zero, aka if it's hotter than, I don't know, like higher temperatures than like 30 or negative 60 or 60 degrees Kelvin. What is it? Which ends up being was like minus 240 degrees Celsius. Just for a little reference. So, i.e., if it's less than, oh no, excuse me, if it's slightly greater than several hundred degrees normally above zero in Fahrenheit or Celsius, that's a high temperature superconductor. It's usually not close to room temperature because room temperature is about what, like 20 something degrees, 23 degrees Celsius, something like that. It's basically we are above zero. We are above zero. To get to a room temperature, aka room temperature means a higher temperature than high temperature. It confused the heck out of me, and I'm sure I'm the only one it's ever confused there. But yes, hey, XYZ, yes, yes. That's the thing. It's like I can do so, and I'm happy to entertain speculation. That's totally fine. It's kind of like what happens if you take the magnitude of Earth and you invert it. Like, take the mass of the Earth, put kilograms squared over it, so you'll get out the magnitude difference from kilograms of dimensions. You get about the Z boson mass. It's basically just kind of a random thing. Hold on, let's do this. Sharing Wolfram. Oh, let me share this tab instead. There, switch. Okay. So like, hold on. G squared Z boson. Yes. So we got 2 units of mass over a unit of mass. All right. I have no idea what 6 times 10 to the 24 kilograms is. Oh, about 6 times 10 to the 24 kilograms is about the mass of Earth. And again, it's a little bit different, but I mean, that's kind of cool. I mean, if you take like the electron, just do electron mass, you're going to get your standard, I think like G-type star or whatever, like the sun is. So you get about half a solar mass. So I thought it was cool that its lifetime was about 44 billion years. Yeah, so you basically get about half the mass of the sun. So I mean, that's kind of cool. Again, this is just based upon our reference scale there. And to say, okay, maybe the sun is approximately the density of water. It's about 1.5 times that. So it's like sun density. Yeah, so it's about 1.408 grams per cubic centimeter. Okay. So it's, yeah, it seems to have some higher, yeah, a little more, about 10 times the gravity of Earth, it looks like. So, again, that's not one, but heck, I didn't even know that until Shiloh randomly says, like, yeah, the sun's about the density of water. Why? Because Shiloh's an actual scientist that has a published paper in Nature about water and some of the interesting effects that it has. So he's been working on since his like PhD. That's a random fact. Again, I can't connect that to anything. I can't just say, oh, well, that's gonna be what it is. I mean, that would. Here's the thing. I understand. I would love a lot of these things to be totally right. I'm very biased because, heck, if you can show that there's a significant connection there, it's like, well, number one, it's a total narcissist. So it's like, I love attention and everything. So it's like, I love folks to say, oh, that's great. Pat in the back memes. Okay, that's great. But it's like, if I can poke holes in my own argument, I'm gonna go around and poke holes into other people's arguments to try to be that guy. It's like, well, you kind of run into a thing here. It's like, I gotta be able to criticize myself because if we can't criticize ourselves, it's like, listen, as somebody that's huffed a lot of my own farts, why am I just gonna seal myself up and just huff my own farts? It's like, that's fantastic if that's all you want to do, but it's like, if you're actually curious about what the heck is going on, I at least say that I'm curious about what the heck is going on, I should I should actually give some credence to the criticism and just rather than just like hand wave it away like I would criticize other people doing, I gotta criticize myself and be like, yeah, I'm doing some hand waving here. And if that happens to come from a large language model, an agent like ChatGPT, it's like, that's fine. That's fine because it's like, it's just going through the known literature and stuff. It's like, all right, it's got the known literature and it's pointing out why there are issues. Yeah. It's saying that there's blah, blah, blah. So let's actually just go back to it. And so I can detail its full response. And again, hey, maybe there was some there, but it's yeah. You got to be able to reflect upon logical argument. And again, this is just because I was just taking a reference scale and relating it to another reference scale. Um, excuse me, I was taking our dimensional just unit ones. I could still say this argument, but it loses its oomph. It's not a direct one-to-one to define structure constant. Because ultimately, if you're relating something, you need to relate something of a magnitude within a scale to itself. Because the reason the fine structure constant works is because you get elementary charge squared, so the charge of an electron over a proton. And if you're relating to all those other constants are going to have to come out to be charge squared as well, which it does, which happens to be the Planck charge. So again, the ratio between the elementary unit of charge and the Planck charge is as J1 or the square root of the fine structure constant, which means the fine structure constant is that squared relationship between elementary charge and the Planck charge. Okay. That was the whole thing. I just took the ratio of the Higgs boson and divided it by the Planck mass. I'm like, oh, this happens to hit like the first three significant digits. All right, that mass scale, that ratio is interesting. That is the hierarchy problem. Now, if I'm going to say that is the magnitude of h bar, it's like, but h bar is it's not a dimensional, it's a ratio. If you had like h bar and it was like an elementary unit of action, and you had another action, you could cancel it out there. But it's like, well, this is literally how we're quantizing things. This is how we're quantizing these things. It's like to just say it's that minus those dimensions. Again, unless it's literally magically the scale of everything, and even here it pushes back. So it's like your realization is a quick one. You said the only way we would be able to claim significance is if we somehow managed to choose the correct scale of expression. The answer is there is no correct scale of expression for dimensionful constants. Nature does not care whether we measure action in joule seconds, erg seconds, GeV, inverse, or Planck units. As a result, if a result depends on that choice, it cannot be fundamental. What would count as significance? This is the constructive part. A coincidence would become meaningful only if all the following were true. The quantity is dimensionless. Okay. It is independent of unit system. If it survives rewriting in SI, CGS, natural units, Planck units. It cannot be removed by rescaling fields or redefining units. Examples that do qualify. Alpha, the fine structure constant, approximately 1 over 137. Mass of the Higgs divided by the Planck mass. Mass of the Higgs divided by the Planck mass to the fourth, to the second. The Higgs self-coupling, lambda, it's about 0.13. Maybe about 0.129. Again, I have my own speculation for that. No idea if it's true or not. Ratios of correlation lengths, aka the Planck length, and then the reduced Compton wavelength of the Higgs, which It's basically going to give you out the same magnitude between the difference in scale from the Planck mass to the Higgs mass, or vice versa. I forget which inverting does it. These survive every unit change untouched. Okay. Clean conceptual summary. It's saying that I should bookmark this. So again, this is something that I think Kurt Jaimungo put this up before because I mean, heck, I think it was even happening to the archive. You're getting like a lot of AI agent based generated papers and stuff like that. I got nothing wrong with that. Heck, I give ChatGPT a citation in my Wolfram summer school project. Why? I'm like, well, help me with code. Why am I gonna lie about that? It's like, no, I didn't do all this by myself. I got a lot of the framework for it. Okay, I can go in there and tweak it and kind of learn from that. But it's like, did I do everything by myself? No, no. These are the tools I use. Cite your tools. Cite your sources. But long story short, as Kurt said, it's like with a lot of the earlier version of this stuff, it would say things, and a lot of times I think one of the it was an article I forget a number of different folks were talking about. It's like a lot of these LLMs were they wanted to be agreeable, or they were very agreeable, and it's like it would even end up contradicting itself very often, where it's like, well, you said this here, it's here, but it was saying things that you wanted to hear. No, I love nice words as much as the next person. Heck, I love people flattering my ego. It makes me feel all warm and fuzzy inside. But again, if we're attempting to do science, we want to be able to survive criticism. That's the whole point of peer review. It's like, can you survive criticism? Because if your idea truly holds merit, if your idea holds water, so to speak, you should be able to survive criticism. Because if your argument actually holds water, then things should actually make sense. If you're using logical argument, and I'm not just saying it's like, oh, I'm just gonna say like some mean words. Here's an ad hominem attack. I'm just criticizing somebody's character or something about them. It's like, well, that's very lowbrow, isn't it? It's like you can do that, and again, I saw something that was attributed to Socrates, but then again, maybe it was Eleanor Roosevelt or something where it's like something saying along the lines of like strong minds deal with talk about ideas. Average minds, whatever that may or may not mean, talk about events. And quote unquote weak minds, whatever that is, just talk about people. Wait. Now, I'm not sure about that quote, and I don't really like how it's like great minds, average, weak. What do you even mean by that? In which context or everything? I think the modern, at least growing up in the 90s and stuff, was like, oh, those tabloids. Yeah. You get tabloids, you get your weekly world news, you got your Inquirer and stuff. Like, what is it talking about? It's like, it's talking about like people and all the gossip and everything. That's totally fine. Don't get me wrong. It's like, I love a good dumpster fire like the next person. I love drama and everything. Why would I lie about that? It's not like occasionally some of the folks that you may see saying, I hate drama, seem to we always be around the same scene of drama. I know these poor people that hate drama that always seem to get caught up in all this drama and talking about it and everything. It's a weird paradox. America runs on Dunkin'. I'm not a paid spokesperson for the Dunkin' Donuts Corporation, although I like money. Let's see where we at. Oh God. So as that's commenting, it sometimes freaks me out to think about how much ice could be floating around the edge of the cosmos. It's like I've read simulations of water in large quantities doing really weird things. It's water is for beings that are made up of mostly water. We're still discovering all these crazy things about it. And that was it. I need to get Dr. Michael Hughes back on. Because we went, it's probably about a year and a half, 2 years ago now. we're just on like one of the Demystify Sci Sunday things, and I'm just talking about like, oh, there's like Lieb's square ice constant. What is that? It seems to be related to 20. What are they're mathematical constants dealing with like lattices? And what is Lieb's square ice constant? I'm like, it's got to be something weird. It's literally about the relationship because water is like it kind of forms like a 90-degree angle. It's kind of like literally the corner of a square. You got a corner of a square. You can kind of like form it with another quarter of a square. It's like you can start literally fitting together like cubic lattices. All right, that's pretty cool. Like I played with blocks and Legos and connects and stuff. I that makes sense to me. I could take some marshmallows and some little toothpicks and stuff. Like for like the week of physics class in high school that I did take. Yeah, we did stuff like that. That's I can wrap my mind around that. Well, apparently, there's a whole bunch of cool mathematical properties, and occasionally it might pop out in something. Does it actually mean something? Well, maybe there are some actual applications in physics and chemistry, but that's a very interesting thing. Uh, let's see. Jox is asking about, I believe, video game related double tap methods and everything. I'm not gonna say I've gone over. Oh, dude, I've totally gone overkill. Whether it's Mech Warrior or anything, it's like that's why I love video games. It's like, all right, I've got I've got an enormous amount of LRM 20s loaded on this like 100 ton of or 90 something ton of salt mech because well, yeah, the Dire Wolf, Mad Cat, all that jazz. Um, yeah, if I could just have all these things and just do an alpha strike and just watch, that's all these again in a video game. Rockets and missiles are laying down upon an opponent mech and just watch it explode gloriously. Oh, I love that stuff. Um, yes, I've done extraordinarily brutal things in and out of video games. Yes. Uh, I'm not a good person. I'm not a good person. Uh, well, it's it. Okay, so that's why this is one of the things that I've been doing because it's like, all right, well, if I want to actually do physics things, like if, and again, one of the reasons I'm bringing this up is because it's, well, if I'm running into a problem, it's like, well, again, I want us to have the. This is one of the things because it can be uncomfortable to bring up things, especially if folks get really into something. It's like, I really like this. This is nice. A lot of times, you don't want to rain on somebody's parade and just be like, nah, this is wrong and stuff. And actually, this is if the problem is if I'm going to make that saying and I'm like, all right, I'm taking an elementary unit, I'm dividing it by a reference unit, and I think there's something significant there. Okay. Maybe that is the case. Maybe we literally just got lucky. Maybe there are a whole lot of other smart people that took a look at that and realized there's a problem with that. That's some folks have pointed out to me. And again, even at this point, it's like some of the main criticism I and that have had. It's like, well, if in your primary equation you're taking the Planck mass and just taking the magnitude in SI, dividing it by kilograms, at that point you are saying the kilogram has significance. And again, the kilogram in reference to water does have that, but now you're going to have to try to define the second from that. And again, to be fair, if you did have the kilogram and the meter defined, and okay, if you had the meter defined, you can define the second by the speed of light. But again, now you are asserting like water is prime. And again, assuming not just water, the reference density of water, assuming it is 1. So like the levels of magnitude you can have, and again, maybe that is the case. I don't have the answer. And even still, I was referencing an older number, which matched my number. To be fair, when I provided the CERN document for it to actually read through, I was quoting 125.38 GeV for my Higgs mass, which is literally right there. It's literally like almost within the uncertainty error bars for that estimated value. It's actually about it was actually about 125.05. So I'm like, all right, like 2.8 sigma. maybe. But again, I don't know. Uh, I'm just I'm doing this one because also I did need also some other content as well. Yes, I'm doing this late at night, but I'm like I also do need to start getting back on a schedule and everything because oh, I'm sorry, XYZ. I wasn't even answering the quite. Long story short is I've been sitting down with Chad and everything because a lot of times, okay, you go to Wikipedia, you get a general equation. Here's an equation. It's like, okay, is this the actual equation? All right, go to the citation. Where is it citing from? Okay, it's citing from something about 30 years ago. I look at it, I'm like, all right, well, this is probably why we assumed that we were going to find something at the Large Hadron Collider, or at least be able to verify the blips that we got at the Tevatron, because apparently the standard model works so well in these magnitude relationships. Long story, what is it, the Higgs vacuum expectation value, or basically this lambda here. So this little thingy that it has here, the Higgs self coupling, is literally defined as the Higgs mass squared divided by the vacuum expectation. Excuse me. What's this actually doing? Let's go over to here. Can we? Oh, God! I wasn't even. Am I sharing? Hold on. Let me swap my tab. Sorry, I wasn't even on the right thing. Hold on. Let's go back. Share screen. Window. All right. So, all right. So, example. Okay. So the Higgs self-coupling is this defined thingy right here. All right. It's about 0.13. So that is a dimensionless knife. There's a caveat there. It has you can express an Lagrangian as having some, I think maybe charge or something like that. The Lagrangians are a very interesting thing. And again, I was gonna do some videos. I'm like, oh, let me criticize like normalization and stuff. And it's like, yeah, there might be some criticism, but it's like, again, criticism is fantastic. I see a lot of criticism out there about a great many things. And it's like, okay, that's fair. If you want to criticize, that's fine. Just again, hold up mirror. Again, I can see a little cut out of myself. I'm looking in a tiny little like 1 inch mirror on a screen. Yeah. Any vector of quote unquote attack or critique that one uses, I mean, just why wouldn't somebody just use that same critique against you? That's the thing. It's I believe there was a mistress of mayhem at one point that said, "Be ungaslightable." That's the thing. Don't give people a reason. If I'm doing something blatant, it's like, well, there's a unit thing here. That seems like a valid criticism and everything. And I just sit there and be like, just yes, it means that that's meaningful. What the heck evidence do I have? So like, okay, this thingy right here. Let's go over here. So just take Higgs boson, Higgs mass squared divided by 2 Higgs vacuum expectation. Oh God. Expectation. Oh, you. I think that will work. Byte. Here we go. Oh, it needs to be in C squared. Sorry. It needs to be in Higgs mass energy. That's my bad. So the Higgs mass in giga-electron volts or its energy form. All right. Mass for energy. Oh. No. There we go. That should. What? Let's just. That's. Why is that not working? Should just be 246 giga electron volts. Yeah, okay, about 247 gigaelectron volts. Oh, value. Here we go. Yeah, verbiage matters. God, no, I copied the wrong thing. I hit C again. What a noob. All right. That should give us. Okay, why is this not? Why is this not working? Okay. Here's what we do. I'm just going to put in the word 247. 247. 247 GeV, because that's what it said. Oh! Total user error. Should be the Higgs mass times C squared. That's the mass energy squared. Again, this one's just all user error. There we go. See? Those small errors used to take me literally an hour or so to find out. I remember I did a stream like this, I think like 2 years ago. Oh god, has it been that long then? Yes, when I just started going on my physics monastery arc. I did a live stream at the monastery. I was upstairs and I was trying to go through some calculations and do some stuff. And I ran into some issues. And it was one of the most excruciatingly cringe things in the world because it's like I had very little user knowledge. So it's like when I made an error, it's like, oh my god, what am I doing wrong? And then it was just telling me, I'm like, I'm getting dimensions. It's supposed to give me a dimensionless thing. Well, I'm supposed to do the Higgs mass in energy. It's the Higgs mass times c squared. But I'm supposed to take that whole thing and square it. I was squaring the mass. If I did c raised to the 4th, then it would have came out. But because you see, we're getting 2 Higgses here, because there's a 2. And we're getting 2 c squares, because we got the 2 there. And yes, I'm doing my terrible, I apologize to my New York friends, New York accent here, because now we got 2 Higgs vacuum expectations. Why? Because it's got the 2 and then times 2. Why? Because we like doing 1/2 like MV or something like that. I don't know. Long story short is that's where you get this number from, i.e., that's where you get the Higgs self-coupling from. Okay. And again, I have my own speculative things that who knows whether or not that's true or not. Again, rampant speculation on my part. Um, but that's all I really do. Like I say, it's like I'm a gamer. I go through, I play enough things. Like just doing that right there, it's like, what was I doing? I was just doing different combinations of things. It's like you get a new fighting video game. You have your standard directional controller. What are you gonna do? What's the first thing you do? Quarter quarter circle punch, Hadouken, shoot a fireball, shoot the ice blast, shoot a whatever. Why? Because that's what I'm used to. So it's like, all right, if I got a thing, it doesn't work because this was here. Oh, let me change this over here. Let me multiply rather than divide. So if I multiply these things together, oh my god, I'm getting like energy to the 4th. It's like, what the heck do I do about that? I don't know. Let's take the 4th root of that, see where that goes. What am I doing? I'm trying to do literally a 360 high punch and do a spinning pile driver with Zangief. Good luck trying to do that. I I know there are people that can do that. And it's a terrifying thing because it literally takes like half your hit points. I wasn't so nimble. I did not have the coordination to do that. I'm not the person winning a Super Smash Brothers tournament. I think one of the last people I heard was like a 10-year-old like using the Keyblade wielding Sora. Whatever that series of words means. What is this? 0.85 Higgs vacuum expectation value. So I'm like, okay. This doesn't mean anything. Okay, that I was gonna say if that was mega electron volt, that would be about the range of the strong nuclear force. Again, what does that even mean? It's 210 GeV. I don't know. Okay, but the whole point is, again, be wary. Be wary. AI and a lot of these AI is a very nebulous word, but it's like let's let me pause and okay, let me get back to what I was trying to say to XYZ. Long story short is I was spending a lot of time and having I'm like, explain to me how a Lagrangian works. Just show me how I would construct the Higgs Lagrangian. Because I'm gonna be looking into this. I'd like to see logical things and how they connect. Why? Because if I'm gonna make some radical claim, maybe I should at least go through the calculation. So the long story short was, when XYZ was commenting about you need to double check a lot of these things, I'm like, all right, it's writing things out. I'm like, just explain the Lagrangian in SI. Just show me all the units, show me the formulation, and we'll start writing things out. It's like, okay, we're using a normalization factor of either like H bar C, or you can do whatever, like 1 over length, or a lot of times we'll do like the square root of joules divided by meters. It's like, well, what is this? You take energy. Energy is mass c squared. If you're dividing by meters, you're taking one of the length terms, or one of your length terms out. So you have mass, one dimension of length, and then 2 dimensions of time. Well, it's force. It's force. It's mass times acceleration. Acceleration is distance, and then 2 things of time in the denominator. Because if it was just a length divided by a time, that's speed. Length divided by time squared, that's acceleration. So rather than just cruising at constant speed, you are accelerating at a particular rate. Okay. So I'm like, all right, well, you're setting these things up in force. And then why? Because you could also use like H bar C, which is basically bending stiffness, which is action times maximum speed. Okay, that's cool. The long story short is it would show me these factors, and I'm seeing all these like indices and all this stuff. So I'm like, all right, go through. Let me do the calculation. Let me do the calculation. I'm like, eventually at one point, it's like, all right, you've got this stuff minus this stuff. I keep going through, keep going through. It's like, all right, the dimensions match. The change in this minus the change of that. Just assuming just standard numerical factors is 0. Yes, we have set our Lagrangian to a 0. That was probably the happiest I ever have gotten the 0 out before. Why? It means at least structurally, in the roughest sense of the word, it was set up correctly. Because the terms balanced out. Now, if you're going to measure the change in energy, which is the whole point of like the Lagrangian, it's just like, what is it? The change in potential versus a change in kinetic or something. We're trying to measure the energy differences of the stuff going on. Okay. I mean, set up by a lot smarter people than me. Long story short is, at least with the more recent versions of chat, it's done, in my opinion, a pretty dang good job. Because again, if it's read the whole internet, I'm not asking it to do anything new or crazy. I'm just like, just teach me, explain to me in terms I understand. Here are these terms I understand. If you use meters, this, if you use H bar, C, use these things. Basically, if there's some weird, funky notation, basically once it starts getting to Greek, you get a little less confident stuff. It's like, all right, well, or what is this index symbol here? It's like, all right, all we're really saying here is like, we've got this, we're running the index over this, well, this ends up being in this coordination. It's like, well, this is 1 over meters, and then this is 1 over meters. So at least dimensionally, what's going to come out to be is we got an index, like a lower index, we got a higher index. It's like, all right, it ends up being like 1 over meter squared. I'm like, all right, dimension, I'm just trying to start grokking what's going on. And then you see, like, what is it, one of the first loops or something like that. Again, I might just be making up these terms here, confuzzling them with other things. I'll see this other term, and it's like, okay, well, this is like 1 over, or what is it? It's inverse meters squared. And I look at it, I'm like, well, by magnitude and just literally by definition, this is the inverse length. This is the inverse. This is the inverse Higgs-Compton reduced wavelength squared. And it's like, well, yes. Yes, this is. And I'm like, okay. My criticism was going to be of normalization and stuff. It's like, if you set h bar equal to c equal to 1, I now really see why folks set h bar equal to c equal to 1. Because the notation is a whole lot cleaner than all the other jazz in there. Wow. Wow. I see why folks do it. But if my criticism was going to be that, it's, again, I need to be able to criticize myself too. If I'm putting things out there and it's like, well, it's highly speculative or even just wrong, I'd just be like, okay, this is highly speculative, or maybe it's just even wrong. It's Occam's razor, most likely scenario. But I can see why they do that, but I'm like, also, it's very interesting because I'm like, all right, I can at least see that this is showing a magnitude of this in meters and stuff. And long story short, part of the other thing before I got Chat to start talking me down from some of my crazier speculations and everything, bring me back because number one, if I am going down a dead end, I do I just want it to say nice things, or do I want to make sure I can go down a path that logically makes sense? Because if I can poke apart my own argument, who cares if I can poke apart arguments, that's fine. But if I can poke apart the argument, then that means it doesn't hold water. It doesn't hold water, why the heck am I even making the argument if I can just hope other people don't notice? I mean, come on. Other people have already noticed. It's like people pointed out, but it took me literally sitting down, going through, noticing this other fact where it's like, all right, well, okay, the speed of light and frequency of cesium 133, just because we chose that as a clock. If that literally came out to be 1 meter, that's fantastic. It doesn't. It's like 30.66 or like or the inverse of that. So I'm like, I can't say that's a one-to-one comparison because we have set it up that particular way. Now I can add a whole bunch of epicycles, but it's not the smooth, clean thing as saying, well, maybe the was it the squared value between the Higgs, or was it the magnitude difference between the Higgs mass and the Planck mass is because it's the root of action or the amplitude of action. I would love to say that. That would be fantastic. But does it hold? Does it hold? Regardless of unit system. Like, that does not seem to be the case there. It's okay, that magnitude might survive, but it's like, well, what am I saying? At that point, the unit of action has changed by 7 orders of magnitude, but that hasn't. So I can't make the same claim. Oh god, I've been rambling about how I've been wrong, and I need to double check myself via other methods more. For over an hour. Let's see. Where are we at? Blah, blah, blah. Oh, I didn't enjoy a lot of those. Crazy Taxi was a great game. And also, so like Need for Speed. I did like building the cars, and again, it would depend on how you would set it up. But all I know is, what's it, the GT 3000 or whatever. It was one of the best bags for the buck because it had the all-wheel drive, and you could give it a whole lot of high end, and it also helped make navigating things a little bit easier because you gotta be careful with all that rear wheel horsepower and everything. So again, I was not a professional driver or anything, but uh, but oh, that's the thing, and one of the reasons why I say that XY is just because I'm like, all right, well, get a cringe picture of myself, like, and that ChatGPT, and it's like, all right, just keep track. You can say a whole. The thing that I took from Professor Norman Wildberger, I think he's now a retired mathematician from the University of, oh god, I forget, somewhere in Australia or New Zealand. Apologies. He's like, repetition renders the ridiculous reasonable. I can say something a whole bunch of times. And again, I did corporate sales for like a decade where it's like, if you say something with confidence and conviction, some people will just agree with you. Why? Maybe it sounds good. Maybe you like the bit of that person's jive. Maybe you think they're kind of cute. Maybe, hey man, full disclosure, I totally follow people because I'm like, that person is pretty. Okay. Or maybe they just said something I agreed with. It's like, that's great, but if what happens if everybody is just quote unquote agreeing with you? Then again, the antithesis of that is, well, if what if nobody's ever agreeing? Then you're probably also not gonna get much done. So what is it? Something up something balance. I think this is why I did the whole gray Jedi thing, because it's like flowing through all there is balance. I still need to learn that quote. I feel like that's something I should open my mental faculties up and actually spend some more time on. But I don't know. Well, I've been rambling on for an hour about how I was wrong about a whole bunch of things. But again, if you're gonna, what am I doing? There we go. All right. So it's getting late, and well, we seem to be within about 1 minute of 11:37. So we will wrap it up at that point. I'll put us about 1 hour and 12ish minutes in here. So with that said, it's okay. Again, a lot of these large language models and agents that can be good, and I'm not saying people can't discover fantastic things with them. At least for me personally, I think this update, this more recent one, has been more rigorous and stringent. I found it useful. Again, everybody's individual usage and what they find useful may vary. Again, I ain't anybody's dad, as far as I know. But with that said, thank you all for watching. Take care of yourselves, everybody. Have a happy new year if I don't see you before then. And with that said, peace out, everybody.